In this video, I'll go over how to prepare alcohols using Grignard reagents. So, Grignard reagents react with ketones and aldehydes to introduce one R group and form an alcohol. So for example, pentanone. I'll react this with the Grignard methyl magnesium bromide. And basically what a Grignard does is it introduces a metal, magnesium, in between a carbon and a halide, so chlorine, bromine, or iodine. Basically what the Grignard is now is it's just a source of nucleophilic carbon. So you can think of it as just a methyl anion. Obviously a very strong nucleophile. This will come in and attack the carbonyl. So I'll have now a deprotonated oxygen in the methyl group I just introduced. Now I add water in, because water can't be present in the solution with the Grignard, because water will destroy the Grignard. Right? The CH3 anion will just react with the water to become methane. So now I add the water in, protonate it, and I get my alcohol. The reaction with the aldehyde will proceed with the same mechanism. So I have my aldehyde. I'll use the same reagent. So methyl magnesium bromide. So come in. I'll have now my deprotonated oxygen, the methyl group, and hydrogen here. Add water in again. To get my alcohol. Notice the major difference between reacting with the ketone and with the aldehyde is that I form a secondary alcohol with an aldehyde. I have a tertiary alcohol with the ketone. Now, Grignards will also react with esters, but the Grignard reaction with an ester introduces two R groups. And I'll put the mechanism down below so you can see how it does that. So I have my ester here. I'll use the same Grignard I've been using. So the methyl magnesium bromide. Now don't get confused, just because I've been using the same Grignard, that's not the only Grignard. There's numerous Grignard reagents you can use. Basically any alkyl group that you want to introduce, you can make that a Grignard. So you can have a phenyl, you could have phenyl magnesium bromide, you could have ethyl magnesium bromide, butyl magnesium bromide, right? You can introduce whatever alkyl group that you want to introduce. I'm just using ethyl because it's the simplest for seeing what's going on with the mechanism. So it'll come in, attack the carbonyl like it's done with the other mechanisms. So now I have got my O-. I've introduced the methyl group, and then my methoxy group down here. These electrons are going to come back down to reform the carbonyl, and it's going to kick the methoxy group out. And the reason we can kick this methoxy group out is we're in very basic conditions with a Grignard reagent. There's also no water present either in this, because if we had water, that would react immediately. So usually if we have this, it'll be in a solution of whatever ester group is going to be kicked off. So we might have it in a solution of methyl methoxide. So I've now got a ketone here, and I'll have a second equivalent of my Grignard. That'll come in, and now I'm proceeding by the same mechanism it did with the ketone. Add in water now so we can protonate. And I've got my alcohol. Again, a tertiary alcohol, just like with a ketone. Now, Grignards cannot react with a carboxylic acid. So Grignards won't react, well, in this manner with a carboxylic acid. They will react, but all it'll do is, because a Grignard is basically a really strong base, all that's going to happen is, if I have my carboxylic acid here, I react it with my Grignard, and I'll use a different one here. We'll say ethyl magnesium bromide. All that's going to happen is I'm just going to deprotonate, and I'm going to get that. It's not going to attack the carbonyl, and also it won't, if I add more equivalents in, it's not going to undergo an ester, because you're never going to kick off just a lone oxygen atom. That's never going to happen. So all it'll do with a carboxylic acid is deprotonate the carboxylic acid. In my next video on the preparation of alcohols, I'll go into preparing alcohols via either reduction or oxidation reactions.